Greetings everyone, and welcome to another episode of Panhead Mania. Tonight we're going to be looking at wheel balance. To give us a pretty clear perspective of one of the challenges here, I'm going to show you this Timken wheel bearing hub from a 99 Harley-Davidson. When you balance one of these wheels, the first thing that anybody would do would be to pop the spacers out, slip the wheel over the spindle of the balancer with the centering cones resting directly on the inner bearing race of the wheel bearing, so that the wheel spun on the axle center line. If you don't, if you leave the spacer in there, there is enough deflection to allow the spacer to move significantly off that center line, causing a misalignment and an imbalance in your wheel. So knowing that, when we look at the star hub, it's easy to mistake this for the inner bearing race, putting your centering cone in the thrust collar. But in fact, the thrust collar moves independent of the inner bearing race. And let me show you that. So this is the inner bearing race here. This is the thrust collar here. And you can see that there is nothing to index this thrust collar to the inner bearing race. So what happens is if you try to use your centering cone, you can see that there's all kinds of opportunity for error there. So what I did was to make this little tool, which is the same diameter as the axle, allows the spindle of the wheel balancer to go through the center. It aligns this thrust collar because you need the thrust collar to spin this wheel, because the thrust collar and the star hub housing determine the end play of the wheel and actually hold the bearing together. So you need this. So if you run this tool through the center of the thrust collar and into the inner bearing race, now this does not float, and the wheel will turn on the axle center line, and everybody will live happily ever after. So that would look like that. The centering cone goes in here now, everything's lined up, and it stays that way. But that's not the end of it. On the 1967 through 72 drum brake wheel hubs with ball bearings in them, they have a setup very similar to this. This is a Sportster drum brake line drawing, and opposite the brake drum side, the big twin ball bearing wheel hub has the same setup. It has this interesting slotted nut, it has an oil seal in it, and it has a spacer. Now, the spacer on the Sportster is shouldered. I do not remember if the spacer on the ball bearing wheel hub in the big twins is shouldered or not. Then you have the wheel bearing and the rest of the assembly. So you would need a device, unless you take this nut off, which is a pretty significant pain in the ass, if you can get it off without ruining it. So you either need a sleeve like this to fit through the center and line this spacer up with the ball bearing, because of course the centering cone is going to fit inside the spacer. And so just a little heads up on that. If you've tried to balance this stuff and end up frustrated, this is the reason why. So Now we go to these big heavy-duty cast iron brake drums, and we notice that they aren't even close to being in balance. So what that tells you is that if you're going to balance this assembly, you need to balance it together. You need to have the brake drum on the wheel when the wheel is being balanced. And then if you ever take the wheel and separate it from the brake drum, you have to put the brake drum back on in the same relationship, or your wheel assembly will now be out of balance. And in the case of my machine, it turns out that the brake drum, and then I have two brake drums. I have my original here, and then this is a brake drum from 1963 to 66, which I'm going to run. And this brake drum, as my original, are off by approximately 1.5 ounces. And which results, so if the swept area is approximately 4 inches from the center here, which it is, we'll just round it to 4 inches, and the wheel weights on the wheel are approximately 8 inches from the center, and it's a little less than that, but let's keep the math simple for the example. That means it will take twice the weight here to or half of the weight. So if you put 1 ounce here to balance this, it will reduce the weight at the 8-inch point by half of that. So this weight on this drum is actually 1.9 ounces, but it's a little heavier because I couldn't run it out to the edge because the lug was in the way. But the drum was off 1.5 ounces, resulting in a 3/4 ounce error in the wheel. I thought, you know what, darn it, I'm just gonna go ahead and mark the heavy point here, and this is the front drum here, and I'm gonna run those. Always have the heavy point in the same relationship to the valve stem on the wheel. And that's how I'm going to manage that. And then I thought, well, gee, maybe I should go ahead and put the heavy point of the brake drum opposite the heavy point on the wheel. That way I could get by with using less weight to balance the total assembly. But you still need to make sure that the brake drum stayed in the same relationship to the wheel if it was ever separated. And then I thought, the heck with all that crap. I'm going to balance the brake drums and not have to worry about keeping things lined up if I ever separate the wheel and the drum. So this is my original front brake drum, and this is a new one that I bought. This weight up here is 0.9 ounces. And this one has not been balanced yet, and I'm not going to balance it. I'm not going to run it. But you will notice the casting marks on the inside of the drum on this are here, and on this drum they're here. And if you look at the relationship of these lugs to these, you can see that both of those brake drums, the heavy spot is at the bottom, and they're both off by approximately 1 ounce, which tells me that the manufacturing process is very consistent from the time that this drum was manufactured to the time that this drum, and this is an eBay drum, I couldn't tell you when it was manufactured. If you look at my original rear brake drum, and you look at this brake drum that has not been balanced, you can see they're pretty close. Now this is a 1963 and up, and this is the brake drum off my 62, and you can see that it's still pretty close. The casting number here, this lug is at about 1230, this lug is at about 130, and they're both off about 1.5 ounces at the swept area. So telling me that even between those brake drums, there's consistency in manufacturing. Now to get down to the weights, I just made these out of some flat stock. I did epoxy these to the drums. I did not want to weld them. At first I was going to. We did a little practice piece on some cast iron, and it was very easy to weld, little spot welds, nothing heroic there. And then I thought, you know what, I don't want to do that. If you choose to do something like this and you want to epoxy them, you're going to have to sweat the epoxy. It's got to handle a lot of heat. I'm thinking that in service, these brake drums can reach somewhere between 200 and 300 degrees. And so your epoxy has to handle that. And if you had the brake drums powder coated, they're going to have a hell of a lot hotter than that. So it has to be some pretty robust stuff. The stuff that I used was the same stuff that Harley has to hold the little compensating sprocket oil device on the inner primary cover for this later style Screaming Eagle sprocket. It's expensive stuff. Most people probably wouldn't go for it. But I just thought I'd mention it because it's something to be aware of. Give this a spin. You can see that this really is not particularly round. And there is some core shift in there. It's really surprising how far to balance it is. But at any rate, that's it for wheel balancing. I wanted to blow that by you, and hope you enjoyed it. We'll do it again.